The next two problems that we're going to look at are special situations. So we'll see why we call them that in just a moment. Well, the first thing we're going to do, we'll take a look at number 2, is collect like terms. So we look at the left-hand side of this equation. I see that here we have a positive 6 and we have a negative 1. So we're going to collect them by just combining them, and when we collect, we always look at the signs, and if they're opposite signs, we're going to end up subtracting. And so when we subtract these two terms, we end up with a positive 5, and I just bring down that minus 2x. And I bring down the equal sign, and I take a look at the other side. Now the other side has two sets of terms that we can combine. We'll start with these x terms first here. And so we have the positive 4x, and we have this negative 6x. So again, you always have to look at the signs in front of the terms to determine what to do. And so these two terms, when we combine those, we'll end up having to subtract, just like the other side, because they are opposite in sign. This time we have more negatives than positives, so we end up with a negative 2x. Now looking at the constants, which are the numbers without variables, we have a negative 3 here, and we have a positive 8. So again, we are subtracting these two numbers because they are opposite in sign. So we'll go ahead and collect those, and subtracting those two numbers. Can you guess what we get? Well, you're probably right. It's positive 5. The reason it's positive is because we have more positives than negatives. So now we still need to solve. So what we're going to end up doing is we need to get the x's by themselves. If you haven't noticed, though, we've got the same numbers here, 5 minus 2x. On the other side, we have the same numbers, 5 and a negative 2x. So let's see what ends up happening when we start moving terms from one side to the other. Let's try getting all these variables on one side. So when we do this, I'll go ahead and add this 2x to both sides. Now when I add 2x to negative 2x, I end up with 0. But normally we just end up with 0 on one side, and we have an x on the other. But here, both x terms are canceling out. So let's see what's left over once we're done with that. Well, we have a 5 equals 5 with no x terms. But we're trying to solve for x. So what do? Well, when the two numbers agree, like they do, where 5 equals 5, then we say x could be any number. And to show that, or to specify that a little bit further, we say that the values of x can equal all real numbers. And that would be our answer. So once in a while we'll end up with that situation where we end up with the x terms canceling out and just two numbers and the equal. Well, this is what we'd write down. X is any number. We could put any number in for x, and when we do that on both sides, we'll come up with the same value. Well, we have another special case in this next problem, number 3, right next to it. And we'll do the same sort of thing we did on the first. We'll collect like terms. So we have this 8x that will combine with the negative 9x. And when we do that, we end up having to subtract again. And when we subtract these two numbers, we end up with a negative 1x. So you can see how we're taking them away because they're opposite in sign. So here we have that negative x, or negative 1x. Bring down the plus sign, bring down the 6, bring down the equal sign, and on this side, I've got some other terms I can combine. So I'll go ahead and collect this positive 2 here, and I'll collect this negative 15, and again I'm subtracting these two numbers because they are opposite in sign. So when I do that, I end up with a negative 13. I just bring down this minus x. Now just looking at the problem, here we have, this time, a negative x and a positive 6. On the other side, we have another negative x and a negative 13. Now, if you didn't notice anything about that and you just kept on going, let's see what we'd end up with. Well, the first thing I'm going to do is try to isolate the variable. So I'd probably add x to both sides. But when I do that, I get the same situation as I did on the last problem. I get the x terms to cancel on the left, but I also got them to cancel on the right. And this problem's a little different, though, because if you look at the numbers that we have, they are not the same. We have a 6 and on the left-hand side and a negative 13 on the right. And those are not the same numbers. 6 does not equal negative 13. So what we say here is not that x is all real numbers, because it's not. X can't be any number. And so the way we represent this is with two words. We say no solution. X cannot be any number. X is not any number, and so no solution signifies that. And there's a symbol we can use for no solution, and that's 0 with a slash through it. So that's a special case scenario that you might end up seeing on your homework, is where we end up with two numbers equaling each other, which in case we say x could be any number or all real numbers, or when the x's cancel out, just like they did in the last problem, but the two numbers do not equal. And that's when we say, well, x can be no number or no solution, or you can simply draw a 0 with a slash through it. So the third type of problem we're going to look at is one in which we have to deal with some word problems. And so we'll see that in the next part.